So we're going to talk about blood types today. How many people in here know their blood type? Okay. Cool. How many people know how many blood types there are? And there's some information in the PowerPoint as well. We'll make sure and check out the PowerPoint. All right. The basic blood types are A, B, AB, and O. So there's four basic main primary blood types. And we have a couple of things to talk about with each blood type. The first thing that we're going to mention is a blood type is named for a surface marker that can be seen on the red blood cell. And the surface markers on the red blood cell are known as antigens. So for example, this isn't what it really looks like. This is just how I draw it. There's a little red blood cell, and there's a little antigen, a little surface marker. We say antigen, you might be thinking receptor because we've talked about receptors on the surface of the cell, but they call these antigens. And this antigen is called the A antigen. So they call the blood type that has those, and it's not just one. There's lots of them on there, but they call that type A. It's really pretty basic. Type B, then, you want to take a wild guess. Just go out on a limb for me. Yes, it has the B antigen. It does not look like this in nature, but hey, I can draw a sideways B, and that makes everybody happy because you can see it. So this kind of looks like an A, and that kind of looks like a B, and we're all good. Now you got to really go out there and stretch your mind. What does type AB have? Why, it has both A and B antigens. And where are these antigens? On the surface of the red blood cell. They are part of the red blood cell. And then lastly, we have little type O. Anybody study ahead and already know about little type O blood? It has no antigens. As far as the AB blood types, the surface of this blood cell would be empty. Okay? Now, A's and B's aren't the only ones. There's like 30 other little minor ones. But we're not worried about those right now. We're just worried about your main primary blood type. The interesting thing about blood is that there's two parts. You have the cells and you have the... About blood, you have cells, formed elements, and you also have plasma. There is a portion, and I like to put, by antigens there, I like to put RBC, just to remind everybody that's on the red blood cell. Well, there's another part to each blood type called an antibody. Now, I know you associate antibodies right now with the immune system, probably, because we've talked about them just a little. However, blood also has antibodies in it. And the way that it works is this. Really, we're born with no antibodies. And depending upon what blood type you have, you will develop antibodies. You will develop the appropriate antibodies in your blood according to this formula. If you have, and I'm going to just draw right here and I'm going to erase it in a second, so just so you know, because I want this table to look nice. So don't draw this, whatever I'm putting right now, don't put it in your table that you're making. Okay, do it somewhere else. You can write it, just do it somewhere else. If you have type A blood, that's an ugly red blood cell, but there it is. Here is an antibody for A. Do you see how the shape kind of fits right there? It's a bad drawing, so it's not exact, but hey, why not? Do you think that you want these things to stick to your red blood cells and cover them up? The answer is no. You do not want that to happen. Okay? Antibodies are made to stick or attach to the antigen and cover them up. And actually what that does is the way an antibody is, this isn't the real true shape of an antibody. We'll see those later on. But what the antibodies do then is they would cause other red blood cells to stick to that and other red blood cells to stick to that. Do you think that you want your blood to clump inside of your blood vessels? That sounds like a bad thing, right? It's different than clotting. It's clumping all up together. But we do not want that to happen. Therefore, naturally, if you are type A, would you develop the antibodies for A? That would make no sense, right? So what do you think type A people develop? Right, and they call them anti-B antibodies. The reason they call them anti-B is because they bind to B. So they're kind of against the type B blood. Well, by the same token, I'll draw this one. If somebody has cute little B blood right there, do you think that they want these things floating around in their blood to come over and attach to them? The answer is no. So what did they develop in their blood? Look, they develop the ones that look like that. They develop the anti-what? Anti-A. And we call it the anti-A. What word goes with it? Antibody. Antibody. Now, blood types are very easy to understand and to see. It takes some time because there's all these A words. And you got to get the A words straight and you got to figure out where they're at. So let me recap for you. 4 basic blood types. Each blood type is named for the blank on the surface of the red blood cell. Antigen. Named for the antigen on the surface of the red blood cell. When we're young, we develop antibodies to our own blood type or not? No, to the opposite. Since the only 2 antigens that we're talking about now are A and B, if you have A, you develop the antibody for B. If you have B, you develop the antibody for A. You want to take a wild guess what you develop if you have both of these on there? None. Good answer. Those people would have no antibodies. Why would they have no antibodies if this is your blood? Because this one would clump and this one would clump, right? Either of them would clump. So naturally occurring, you would not get those or those for type A, B blood. And then last but not least, the little O people. Raise your hand if you're a little O person. Wait, where are you sitting? I want to see this. Raise them up. Look, look. Oh, you ruined it. See, they were all together. You're supposed to be sitting with them. Okay. Type O has naked cells, so they can have this floating around, and they can have this floating around, and it's got nothing to stick to. Do you guys see that? Type O, therefore, has what? Both the anti-A and anti-B antibodies. And that's blood types. That's easy. That's the easy part. Naming the blood type is the easy part. I'll probably ask you for one of the blood types. I'll just pick one, and I'll say completely describe a blood type. Oh, who knows? I might pick all 4. Say completely describe all 4 blood types. I won't tell me the antigen and antibody because I don't want to give you those words. I expect you to know if I say describe all 4 blood types, you should do something like this. And then the fun part is the next page. We need to see about blood donating. We need to know, we need to be able to see which person can give to which other person based on blood type. So when we do this, we're going to look at a very specific formula. We are going to look at the donor, and when we look at the donor, we are only going to be concerned with the red blood cells. We're going to ignore the plasma of the donor for now. We're not talking about donating plasma. We're talking about donating blood, which gives the blood cells, which carry oxygen. And on the person that receives the blood, what would we call that person? Yep, recipient. You want to take a wild guess what part of their blood we're going to look at? It is their plasma that is important. Because you have a lot of plasma, a lot more than they'll be giving you in the blood. So you have a lot of antibodies that are already there in your blood. You don't want to receive any cells into your blood that your naturally occurring antibodies would attack and clump. And that's the formula. See, as the person that receives the blood, you need to make sure that you don't get the wrong red blood cells in there. That's the important key. Right? When they're donating plasma, they mess with the plasma. They can take out the antibodies if need be. There's not going to be enough of them in that blood to clump your blood together enough to make any kind of big deal. So this is the formula that we look at. The donor's red blood cells and the recipient's plasma. What is on the donor's red blood cells? Good. Antigens. And what is on in the recipient's plasma? Antibodies. So here's what we're going to do. We're going to just work it out and see what happens. If a donor is type A, I go about figuring this out in a kind of backward fashion. I want you to understand this. This person cannot donate to people that have what floating in their plasma? Anti-A, correct? They cannot give to the anti-A people. Flashback to your chart. Who has anti-A in their blood? Type B. Who else? Type O, right? Remember, in the plasma, type O has both. Okay? And type B has anti-A. So we know they can't give to anybody with anti-A. So they cannot give. And this part, notice how I'm pushing it off to the side. This isn't what I usually ask you. I don't say, who can they not give to? But that's the way you figure it out. We know that they can't give to B or O. So who does that leave that they can donate to? A and AB. Do you see that? Would it not make sense that you could give to your own type? That kind of makes sense. Okay? And type AB blood has empty plasma. And if it has empty plasma, you can put whatever cells you want in there. So by that token, what do you want to guess about type AB? It's the universal recipient. We're going to see type AB on all these. Okay? Let's do type B. Type B can give to anyone that does not have what? Well, let me rephrase that. They can't give to people that have what? Anti-B. Who has anti-B? Type A and type O. I know it takes time to work with this before you can just spit the answer right out. Right now you're probably having to look at your table. But on the test, you can draw your table out, and then you can look at it and figure it out. That means that type B can give to itself and AB. Are you seeing a pattern here? You can donate blood to your own type and AB. Typically, that's how it works. So by that formula that I just gave you, you can give to your own type and AB. Who can AB give to? Well, that would only be AB. They can only give to AB. Why? They have both antigens on the surface. So if there is anti-A, it would clump. If there is anti-B, it would clump. They can't give to anybody that has those things. Well, everybody has them except other ABs. AB can only give to AB. Where's my type O people again? There we are. By the way, I'm one of these people. Type O has naked cells, correct? They're little empty cells. You can put those cells in any blood because there's nothing for them to stick to, those antibodies to stick to. So therefore, type O can give to any blood type. Type O is known as the universal what? Correct. The universal donor. So they can give to A, B, AB, and O. Universal donor. I want you to know that type AB is the universal recipient. The next thing we need to talk about then is the RH factor. And actually, I'm going to have to delete that other recording because I forgot I didn't do the RH factor in the other class, and I should have. I forgot to tell them to read about it. So anyway, RH factor. And yes, there's some PowerPoint information on this. Here's what we just did. Okay, notice anti-A and anti-B, the antibodies form in the blood around 2 months of age or so. It's not an exact perfect. The RH factor, or RH blood groups, different. Instead of naming them, because there's, wow, look at that, 45 different RH factors. We're just going to say a person is either, RH positive or RH negative. You know what RH positive means? It means they have the RH antigen, one of them, or multiple ones. They have RH antigen. You know what RH negative means? No RH antigen. It's all about the antigens. Where are antigens found? Excellent, on the surface of red blood cells. Therefore, many of you already knew this and you were going, I know my blood type, it's O positive. And you were wondering, well, where's the positive part come in? That means you also have RH factor as well. Okay? Now here's the cool thing. Naturally, none of us have the antibodies. It doesn't matter. This one's different than type A and B. You do not develop the opposite antibodies with this. The only way that you develop the antibodies is if you get Rh antigens somehow into an Rh negative person's blood. Because an Rh negative person has no antigen, so they will develop the antibodies to fight that. If that kind of blood is put in them. Okay? So if a Rh negative person is given Rh positive blood in a transfusion, they would develop the antibodies and clump it. All right? But just in their normal life, odds are they're not going to get that blood in them. If an Rh negative person and an Rh positive person decide to become blood brothers and they cut their hands and they shake their hands, guess what the Rh negative person is going to all of a sudden start to do? Build the antibodies. They're not going to get enough blood in there to make a big difference. They're going to have these antibodies. Are those antibodies going to affect the Rh negative person's normal blood? Nope, they're just going to be there. Okay? It's really no big deal. Except when? Ladies. Except during pregnancy. So here's the deal. You know what that is. I drew it before. Okay. He's got a little bow tie on. All right. So there's the little baby. It's a sad little baby. And this is the mom. And we are going to say that the mom, for right now, just go with me. We're going to draw this multiple times. If the mom is Rh positive, is there any situation that would cause her to develop the antibodies to this, to the Rh factor, if she's positive? If you're Rh positive, would you develop antibodies to kill your own blood, to destroy your own blood? So is there any way a positive person could develop them? No. So we never worry about a positive mom. Okay? If there's a positive, Rh positive mom, this doesn't even matter at all. Okay? It's only if the mom is Rh negative that we have anything to talk about here. And if the mom is negative and the little baby that is developing is positive. See, we have this temporary endocrine organ that I draw a little funny looking thing like this. It's called a placenta, right? And what does a placenta do? Mom's blood vessels come in here, baby's blood vessels come in here. There's a little space between them where stuff can diffuse back and forth if it's small enough. Like oxygen, like sugar, right? Like electrolytes. It's made to do that. Stuff can move. Well, if because things are little and stuff happens, some of baby's little blood gets up here, what would mom start to do to those Rh positive antigens? She would start to make antibodies. Here's the good news. It takes a long time. It takes months for her body to do that. It took months for the baby's blood to develop to the point to have those. So by the time the first baby is born, well, I said it wrong, I guess. The first baby is born, before the mom develops the antibodies enough to harm the baby. So the first baby is always okay with this. However, baby number 2, baby number 3, baby number 4, baby number 500. Wow. That's a big uterus. Okay. Each subsequent baby, if they are Rh positive, then the mom already has these. Her body has the memory of that. As soon as the baby's blood gets up there, she cranks up her production really fast, and it harms whatever positive baby this is. Okay? Once again, our formula is the mom has to be Rh what? The mom has to be negative, and the baby has to be the second baby that's, or more, that's Rh positive, right? What if the first baby was negative? Then it wouldn't produce it. So the second baby that was a positive baby is really the first positive baby. You see what I'm saying? So it's the second positive baby, and third positive or fourth positive or whatever. Any other negative kids that come along, they wouldn't be affected by this. So what does it do? Well, it clumps the baby's blood. The red blood cells clump together, just like we said. That causes more of them to be destroyed. And when you're destroying more cells, what does the body do to compensate? It produces more. So you have two things going on, excessive destruction and production of red blood cells in the baby. So they call this disease two things. They look at it two ways. Erythroblastosis fetalis. That means increased red blood cell in the developing baby, right? Erythroblastosis, increased production in a baby. They also call it hemolytic disease of the newborn. Why hemolytic disease? Hemolytic. Blood destroyer, right? Red blood cell destruction, hemolysis. So they name it both ways. Now the good news, when the mom was negative and the baby was positive, it doesn't happen all the time. It only happens sometime. It's a low percentage of the time. But when it happens, these babies usually didn't survive very long. So Rh negative moms get to take a shot called RhoGAM to help inhibit the production of those antibodies. Okay? Rh positive mom never has to worry about that because she won't produce them because that's her own blood type. And she wouldn't produce them for her own. But if it's a negative mom with a positive baby, they give them that. It's a gamma globulin shot. And it blocks the antibody production. So it's pretty cool.